Okay, is this thing on? Camera's on. In my pajamas. Alright, we're going to look at Advent of Code Day 11. Just opened up a minute ago. So I'm only barely late today. Let's see what we got. Reactor. Close this. Okay. New server rack. It's like some kind of a graph. It's their one-way graph. Okay. Okay. So there's one that says U. Ending with the main output of the reactor. Device with the label out. There's multiple outs. Okay. How many different paths? Ooh. Oops. This goes here. Okay. We're going to say here's our graph. We're going to start by parsing. Are they all 3 letters? Well, that's nice. Let's make sure that looks right. Oh, data. Okay, that looks right. Okay. How many different paths are there? I mean, we did something a lot like this before. It can't flow backwards. So does that mean there's no loops? It's more like a tree than a graph, really? Well, I guess it's not exactly like that. So go U to BB, BB to DD, DD to DD, BBE. Okay. Do we start naive? I mean, it doesn't seem that crazy of a input. Let's start naive. What is it? From Collections, import DQ. Can you append multiple things? I don't know, I'm just gonna say. Yeah, I don't know if that is true. Interesting. Well, that makes no sense. Is that the problem? There's multiple outs. Well, what's going on here? What did I do? What the hell's going on? Okay, something is going wrong. That's crazy. Python is a crazy language. That's crazy. Okay. And I'm assuming it's going to get a lot more crazy after this first part. It should be fine for this part. Easy. DAC and FFT. We must find every path from SVR to out. I'll visit either of those. Okay. This also seems easy enough. DAC, FFT. DAC. If wait, what? Okay. See if there's crazy amount of more stuff going on here. Okay. Interesting. Is it a loop? Or is it just going a lot of places? How do I figure that out? Okay. Let's just say the naive approach isn't working. So how are we going to do it? We're going to want to have some kind of memoization. Let's start with just figuring out if there's a loop. Okay. So if we're not double visiting nodes, we make it to the end very quickly. Okay, so what do I need to do? What we need to do is I mean, okay. So we need to count paths from FFT to out. What if we just do that? Is that possible? Interesting. Okay. So we actually can't just do that. Okay. So I actually want kind of what I had before. Is it? Uh, um, what am I thinking? I need to keep the path. All right, well, let's just see what happens. What do you mean it was not closed? Expected a statement? Is that what we want? Doesn't make sense. I need to be going bottom up, I think. Is that right? How the hell do I feel like I should know how to do this. I'm being stupid. Not that different from which one? It's not all that different from this one. 40 different timelines. It's just that it's not strictly linear, right? So what I need to do is like count the number of paths to the child. Okay, we're gonna do something crazy. Maybe that's gonna help. That's the one special case here. Okay. So we did that. Now what do we do? Now we're going to do something crazy. We haven't visited every parent. Let's look. The function. Oh, if how do you do? Oh my god, I'm in the wrong file. Okay, let's just see what happens. I'm gonna say if all in. If all parents in parents in graph uh, what the fuck? Okay. I mean, this is sort of working. Let's go back to the sample input. Let's see. What's here? Well, that's not good. Same. No, it's not one. It's visits. Let's see if that helps. Yes. Okay. Now we have 8. Okay. I think we're almost there. So now what do we need to do? Now we need to figure out how many of them went through each. What is it? FFT. Well, no, this is also not good. Why does FFT? Oh, I see. These are not even. Graph dot items. Is that what it is? Okay. So FFT. It's one visit from AAA. So basically, I want to say what? if current equals FFT, visits 2 equals current visits 0. Visits 3 equals current visits 1. Current visits 0 equals 0. Equals DAC. It's 1 equals visits 0. Current visits 2 equals current. Current visits 3 equals current visits 2. Let's try that. We were close. Oh, you're so close. Okay, let's figure it out. Visits equals okay. So if we're in FFT, current visits 3 equals current visits 2. Current visits 1 equals current visits 0. Equals 0, right? Because now every visit has a pre. Yeah. Current visits 3 equals current visits 1. Current visits 2 is current visits 0. Only two paths. So wait, has this been right the whole time? Out. Have I been bugging out and it's been right the whole time? Ah, jeez. Okay. Is that what I need? So where is this breaking down? Getting a hell of a lot of visits that visited the first one, but not any that visited the second one. Wait, DAC's got so many of them. Okay, and where's FFT? Like, sorry. Why is this taking me so long? I feel like I'm on the precipice of it. Okay, so there's not that many visits here. There's a lot of visits here. Oh. Is this what I want to say? Yeah, that's what I want to say. Now it's going to take forever, huh? Okay, that's fine. We can do this. Equals lane pairs. Let's go back to the sample for a second just to see. Okay. To make sure that looks correct. String indices must be. Oh, okay. 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 Is that going to work? No. Oh, maybe it did. Okay, let's see if that helps. Well, it got me a big old number. Okay. Okay. That was not so bad. Should not have taken that long. But you know what? We did it. And a win is a win. Can't argue with the win, man. Do we want to explain it? I guess we can explain it. Stretch for a second. Okay. I don't even use this visited, do I? Okay. See if that still gives me the right answer. Yep. Let's walk it through. So for part one, it's a pretty simple problem. Basically, they give you a graph. Or it could be a tree. It's one way, so the connections only go from here to here, not the other way. There's no loops, which is great. So basically, you want to traverse the graph. You're trying to find every path from you to out. For the first part, there's not that many paths from you to out. So you can basically just brute force do every single path with no optimization or anything. So that's basically what I do. I parse my graph and I make my graph. So it basically just looks like the key is the name of the node, and the value is an array of all the children. Pretty simple graph for part one. Then I do a BFS. I set up my queue, add my first node, which is labeled U. It's just a completely naive BFS. I get my current node. If it's the output node, I increase my count. Otherwise, I add all the children to the queue. And because there's just not that many paths in the graph, totally fine. Doesn't need any output, any memoization, anything. Boom, 733. For the second part, I kind of noodled around for a while. Took me a second to figure it out. So there's a ton of paths from the SVR node to the out node. like way, way, way more possible paths than there is for first part from the U node, even though it's the same graph. Just the SVR, where you start way further down the graph, and there's a lot of nodes that you just don't touch if you're starting from that node. So it took me a little while to figure this out. I'm not sure that I did the best traversal. It's almost like a Dijkstra's, but not quite. So what I did for this one was I'm not even using this anymore, am I? So my first idea was, let's keep track of all of the parents of a given node. I want to visit nodes only one time. I know it's sort of like a downwards directional graph. There's no loops or anything like that. Since I only want to visit every node once, I want to make sure that I visited all the nodes that lead to that node before I visit that node, because I want to keep track of the number of visits. So what I initially did was I got a collection of all the parents. And then I was checking, like, have I visited all the parents? It's actually much simpler to just get a count of the parents. So I'm going to even clean this up and put that in now, because that was an optimization I had to make anyway. Let's see if that still works. Yes. So what I'm doing is I'm keeping track of the number of parents that each node has. I'm also keeping track of the number of times I've visited a node, and this is supposed to represent if I've hit my prerequisite nodes. So the first item in the array is like, I haven't hit any prerequisites. This is the number of paths that go to this node that have not encountered DAC or FFT. For the first one, I'm saying this is the number of paths that have encountered just the FFT node. For the second index, I'm saying this is the number of paths that have encountered only the DAC node. And the final index is all of the paths that have encountered both the FFT and the DAC node before they've gotten here. So I'm starting from my SVR node. I have exactly one visit because that's my initial node. And it hasn't hit any of the prerequisites. So basically, I do my BFS. I start queuing up my nodes. We'll ignore this for a second. And I check all the children. I'm basically going to add my current amount of visits to my child's visits. And then I'm going to decrement my like parent count by 1, because I'm saying, okay, one parent of this child node is currently being visited. If my parent count is now 0, then I know, okay, I visited every single parent possible. That means that my visit count, what do you call my number of visits, is like finalized. It's not going to change. So now I can append that to the queue and know that like that's solid. If that makes sense. So this way I'm only appending every node once to the queue. I'm not like reappending, which is what was causing me to time out and take things forever. Because if you just do a naive BFS like we did for part 1, it's going to spiral way out of control. My final answer is this huge number, right? And if we were appending each node like this many number of times to the queue, it would just be ridiculous. So instead of appending multiple times, we need to just keep track of like the number of visits up to this point, and just keep accumulating them. I skipped over this part. This is a little messy, but this is how I sort of kept track of if I would hit my prerequisites. I talked earlier, this is no prerequisites, this is one prerequisite, this is another prerequisite, and this is both prerequisites. So basically, if I hit the FFT node, I'm keeping track of that in the first index, or the second item, first index of the number of visits here. So I'm basically saying all of the current visits that haven't hit a prerequisite, now they have hit the FFT node. So that's why I'm moving this index to this index and wiping out this first one. And I'm also saying all of the previous visits that had already hit the DAC node, now we've hit both of them. So that's why I'm moving everything from index 2 to index 3 to represent that I've hit both of them. And then I do basically the same operation for the other node. I'm saying, like, you know, for every previous visit that had hit the FFT node, I've now hit both. So I'm going to increment my final index as like I've hit both. For every visit that had not hit any of them, now I've hit the DAC. So I'm going to increment this one, which is like my tracker for that. Maybe that makes sense. Maybe it doesn't. You see, the code's pretty short. It's not all that complicated. It took me longer than it should have. I was doing some dumb stuff, like instead of keeping a count of the parents, I was like repeatedly checking an array of all the parents to see if they were all there. I also did something where instead of not adding it to the queue, I would add it to the queue and just push it to the back of the queue. That was so dumb. I don't know why I did that. But we got our answer today. Not bad. I do need to actually go back at some point and finish up the previous 2 days. I think I'm really, really close on this one. I've actually have 2 strategies, both of which I think will be successful. I just need to iron out like whatever edge case is preventing me from doing it. For this one, I have some ideas about how to sort of like prune my search for this one. For part 2, it's getting really crazy. I thought I could sort of like brute forces, and then I thought maybe I could sort of backtrack it or something. But it's still too crazy. I need to prune it much more aggressively, and I have some ideas about that. I do think people use some kind of solver for these, and maybe I'll just learn how to use one of those because I've never used one of those before, and maybe it would be useful to learn. But I really felt like I could do it without that external library. So I'm gonna give it a try. But anyways, we did it. Final day tomorrow. Then I will need to go back. But such is life. All right, take it easy, everybody.